Hi, I'm Yasmin Anjana and I'm going to explain about the working mechanism of aeration tank systems mostly based on our site visit to Indawata Consortium in Bandar Terrazak, Kuala Lumpur. The aeration treatment system utilizes the sequence batch reactor tank, SBR tank. They have 6 SBR tanks, and each SBR tank has 2 compartments with 4 units of aerations and 2 units of supernatant decanter. The aeration refers to the supply of oxygen in the water for the consumes of microorganisms. Meanwhile, the supernatant decanter refers to the
So how does the aeration tank in wastewater treatment works? If we look in the flow diagram, we can see that before the wastewater could enter aeration tank, it will go through another unit's operation first to be physically clarified, especially in the grid chamber, and then for the flow rate to be stabilized in the equalization tank. This is because in aeration tank, we focus on the biological treatment of the wastewater. So we need to make sure the wastewater is already physically clarified to enhance the biological treatments of the water. And then the water flow rate need to be stabilized because there is peaks during certain times like rainstorm and so on. So we need to make sure the flow rate is stable to ensure the highest efficiency of the treatment in the aeration tank. So when the water is already physically clarified and stable, it will enter the aeration tank.
We want to remove the organic matter from the water. The air diffuser at the bottom of the tank, shown in the figure, it will produce air bubbles to supply dissolved oxygen for the aerobic microorganisms. When the aerobic microorganisms consume this dissolved oxygen, they will produce ATP, carbon dioxide, and water. They will use the ATP produced to grow and produce more aerobic microorganisms. These microorganisms will help to break down the organic matter poisons in the water. In the water mandatory waste treatment plant, the air capacity used by them was 130 meter cubed per minute per unit. The reproduction of microorganisms and interaction with organic matter will produce a cluster flux or activated sludge. The wastewater alongside with this flux will be transferred to the second clarifier for further separation. The activated sludge, due to gravity, will settle down at the bottom of the tank, meanwhile the clarified water will be transferred to the next unit operation. From the picture, we can see that the activated sludge that settles at the bottom of the tank it produces a blanket of sludge. This sludge will then be recycled back to the aeration tank to maintain a high concentration of microorganisms. Meanwhile, the one that cannot be recycled back will be removed from the system for further treatment or disposal, as can be seen in the figure.
There are 4 impacts of aeration tank on wastewater quality. First, ensure energy savings. Second, improve treatment efficiency. Third, use fewer chemicals. And lastly, improve quality assurance. First of all, ensures energy savings. According to the case study, the population equivalent PE characteristic of conventional activated sludge (CAS) system is 352,000 PE. As mentioned, the industry uses an immense amount of energy. Treatment costs and energy consumption will only rise in line with demand. Consequently, implementing aeration technology that enhance energy efficiency is quite beneficial. A more sustainable industry can benefit the use of affordable, energy-efficient water treatment systems, especially those with effective aeration technology. Second, improve treatment efficiency. The ultimate goal for any company in the industry is efficient water treatment. Water treatment plants can speed up their operations without harming the environment by fine-tuning the aeration systems. Next uses fewer chemicals. The nitrification is a crucial step in water treatment. Operators depend on it to remove nitrogen from the water and to increase its alkalinity. Water supply over aeration systems may result in difficulties with functioning. An internal recycle must stop the nitrifications or anostic zones could become partially aerobic or oxides. Operators usually have to add chemicals to maintain alkalinity levels at a constant pH if the nitrification is limited, which raises the cost. Therefore, the main objective is to make sure aeration systems are not over or under aerating to ensure there will be no other issues. Lastly, improve quality assurance. It is common knowledge that the main goal of water treatment is to keep contaminated water out of the environment, so that it maintains a healthy ecosystem balance and speed up the natural elements of treatment processes. Aeration is a straightforward yet crucial instrument in the water treatment. Water quality requires careful treatment because of society's reliance on it. Reducing and removing pollution which will affect the quality of the water. Moreover, aeration is an important step in treating pollutants of farm runoff, like ammonia.
In aeration tank, there are several parameters that need to be taken note of. First of all, the aeration process requires lots of energy. Aeration process refers to the oxygen supply for the microorganisms in the tank. Next, the air diffusers placement is really important in aeration tank. It influences the flow patterns of both water and air. Proper placement ensures that the air is evenly distributed, promoting efficient mixing between the water and the air. Last but not least, to ensure the high efficiency of the aeration process in the tank, we can determine the respiration rate of the microorganism by determining the specific oxygen uptake rate, or simply called SOUR, or SOUR. SOUR indicates how much oxygen consumed by the microorganism to metabolize the organic matter. Effective respiration means effective degradation of the pollutions. When the SOUR value is zero, it means that it indicates the inactivation of the microorganism, or possibly the possibility that the microorganism in the activated sludge has been killed. This usually can be fixed by reducing the feed to microorganism ratio, feed referring to the organic matter while microorganism referring to the aerobic microorganism in the wastewater. When the SOUR value is medium or high, it means that the microorganisms are not in toxic environments, and it actively respire. So the best step to take for this case is to stabilize the population um, to ensure an efficient degradation of the pollutants.
Let's move to CEB 3023 process safety and loss prevention. As you can see here, this is the piping and instrumentation diagram, PNID for aeration tank, which is connected to a settler afterwards. The contaminated water coming from equalization tank and entering the aeration tank with the help of pump and control valve. Inside the aeration tank, air bubbles were released to enhance the growth of aerobic bacteria. Then, aerated water flows into the tube settler to be mixed with organic coagulant to create bigger clump of slush, so that the slush can be removed easily from the water. After that, some of the slush is sent back to the aeration tank, and some of them goes to the slush drying bag for further treatment. The treated water after coagulation and flocculation process is transferred to the chlorine contact tank. There are few parameters to be focused in operating the aeration tank safely and efficiently. It involves the water flow rate, pressure, air blower flow rate, as well as the water level. To explain further details, we will be focusing on the water level. The guide word here is small. For the deviation, when the water level exceeds the normal level, the water may occupy the whole tank. It causes the sludge to accumulate and raise up to the top layer of the water. The consequence, the sludge buildup can block pipes and equipment. Therefore, for the action, the sensor will detect the increase in water level, send the information to the transmitter so that the air inlet may increase while the air outlet decrease, and the water level will go back to the normal level. There are other potential hazards that can happen during the operation of aeration tank. First, overpressurized tank. Blockages or equipment malfunctions in the aeration tank can lead to overpressurization. To prevent this, installing pressure relief valves can help mitigate the risk. Next, oxygen deficiency. If the air supply fails, the dissolved oxygen level can drop, affecting microbial activity. To prevent oxygen deficiency, implement alarm systems may alert operators when oxygen level drops. Finally, mechanical failure. The aeration equipment could fail, disrupting the aeration process. Preventing measures include routine maintenance schedules and using high-quality components.
Moving to our safety analysis, now we will discuss about hazard study, which is hazard and operability study in aeration tank system. So we identified that there is two critical slots in the aeration tank system. So for the first one is inlet flow to the aeration tank. The first guideway is no flow. The deviation is no wastewater inflow to the aeration tank. The possible cause that this event can occur is due to pump failure and valve closure, and also blockage in the pipeline. The consequences from this event is there's no aeration process and the wastewater will remain unfilled. So the safeguard that we decided to use for this event is redundant pumps, flow alarms, and regular maintenance. So for the second guideway is more flow. The deviation is excessive inflow to the aeration tank. The possible cause that this event might occur is due to pump overrun and pump malfunction. The consequences is overflow and reduced treatment efficiency. The safeguard that we decided to use is flow control valve, high level alarm, and also flow meters. The third guideway is less flow. The deviation is it will reduce inflow to the aeration tank. The possible cause that this might occur is due to partial blockage valve and partial blockage and valve underperformance. So the consequences from this event is insufficient wastewater for the aeration and poor treatment. So the safeguard that we decided to use for this guideway is flow meters, low flow alarm, and routine inspection. So for the second note, this is aeration system. The first guideway is high pressure. Deviation is the excessive pressure in the aeration system. The possible cause for this event occurs due to block, diffuser, and overhead leak flows. So the consequences that might happen due to this event is equipment damage and safety hazard. So the safeguard that we decided to use is pressure relief valve, pressure sensor, and regular cleaning. So for the second guideway is low oxygen. The deviation is insufficient oxygen levels in the aeration tank. The possible cause that this might occur is due to blower failure and blocked diffuser. The consequences in this event is it will cause poor microbial activity and inadequate treatment. The safeguard that we use for this event is oxygen sensor, backup blowers, and regular maintenance. So the last guideword is the no aeration. So the deviation from this event is complete failure of the aeration system, and the possible cause for this event is power outage or blower malfunction. The consequences for this event will cause process halt and potential anaerobic condition. So the safeguard that we decided to use is backup power supply, redundant blowers, and alarm system. So in summary, our hazard study for the air supply inlet and effluent outlet nodes identified that several potential deviations and the associated risks. So by understanding this deviation and implementing appropriate safeguards, we can significantly reduce the likelihood of hazardous event and improve the operability of the system.